Good evening, everyone. Welcome to the devcord topic of the month for Backend Development Week 4. I'd just like to preface this video by saying I just want to apologise, first of all, that this video is not the recording of the live stream, which happened last night on the, checks the dates, 23rd of August 2020. Unfortunately, due to some unforeseen technical issues, we ended up losing the live recording, and YouTube didn't automatically archive the stream that we did. It never actually started streaming for some reason. We're not entirely sure what happened, but we have been looking into it and we're working on fixes for the future so it doesn't happen again. Instead, this is a special one-off recording. I'm going to give the same talk again. I'm going to try and answer some of the same questions for you. So if you were there, it should feel exactly the same. If you weren't, it'll have all the same information. Don't worry. That being said, let's jump into things and have a look at what's been covered in this presentation. First of all, we're looking at two-factor authentication. This was a rather popular suggestion which was made by a couple of members of the community. Thank you very much. We're going to be looking at this thing that you've used a lot. So now it's time to learn about how it actually works. We're going to be looking at it at a conceptual level. We're going to be looking at its basic flow and a RESTful API as well. The next topic that we're going to be looking at this evening is caching, which is that thing that makes front-end developers mad. That's why I like it. We're going to be looking at some of the different types of caching that you can do and some considerations as well when you're building caching into an application. Lastly is my favourite topic of tonight, which is ORMs. You can preserve your sanity with this one weird trick, which is installing an ORM and just deferring everything to it. They are absolutely magical. I love them. DBAs hate it, probably, because of a few reasons that will become clear when we move into ORMs. Also going to be having a look at what they are and how they actually work, because ORMs seem to be one of these mysterious things that you need to get down and dirty with to really understand them. So on to the first topic of tonight, which is two-factor authentication, affectionately known as the onion strat among some people, because you're adding additional layers of security to the authentication process. As well as requiring the user to know something, which tends to be their email address and their password, you also require the user to have something, which is usually their phone. This adds an additional layer of security, so in the event that these credentials are leaked, people still can't log in because they need an extra thing, like the user's phone. The reason why you'd add something like 2FA is because in current year, 2020 at the time of recording, credentials alone are not enough. The way that you'd work with this is you'd create a token. When the user starts the authentication process, you would create a token and you would store this in your database. You would then send this token to the user via some means which are not your application. So you would go outside of your application to deliver this token and then ask for it back. Typically, you would send this token to a device like a phone, and you'd usually do it via SMS. Now, there are some problems with doing two-factor authentication via SMS. I'm aware of these, and don't worry, it is covered in the next slide. The reason that you do this, again, is to protect your users. Let's assume a worst-case scenario. Has your database been dumped out, and have your password hashes been cracked? Well, even with that being the case, with two-factor authentication in place, the skiddies that broke into the database and dumped everything out still cannot log in as the user. So this all sounds rather magical. But how? How exactly would we do this? We're not exactly running a self-service provider over here. How am I supposed to send an SMS message from my web application to a user's phone? The way that you'd do this is you'd use a third-party telephony provider. A telephony provider is basically a company that does all sorts of things to do with phones, whether that's SMS messages, calls, voicemails, that sort of thing. These are companies that do that for a living. They usually own hardware that are known... There's a hardware known as an SMS gateway. This is basically hardware that interfaces with a cellular network and allows you to send SMS messages through it as if it was a phone, except it's not. The way that you'd gain access to one of these SMS gateways is you would use the RESTful API which this provider has exposed. The way that they tend to do things usually, I can't claim to be an expert because of course I haven't built one of these setups, is that they will build a RESTful API that will receive an instruction from the web, and this will somehow get translated into an instruction which gets sent to the SMS gateway. So to actually do this, you just have to make a HTTP request from your backend to this provider. A lot of the time these providers also offer a whole slew of other telephony related services. Perhaps if you wanted to do something a little bit more unique and you wanted to call your users and give them the code, you could probably do that. A lot of these services do offer this kind of functionality. It's also worth knowing some of the big providers in this space. The top two off the top of my head are Nexmo and Twilio. Nexmo seems to be a little bit younger, a bit more developer focused, but Twilio is kind of one of the standard providers. So it's probably worth trying them both out. As far as I remember, Nexmo does actually offer free credit for new accounts, so it's worth checking that out. So now I'm going to move on to an alternative method of two-factor authentication. Like I mentioned, there are some problems with SMS-driven two-factor authentication. The main problem with SMS-based two-factor authentication is SIM swapping. So this would be when an attacker is launching an extremely targeted campaign to get into someone's accounts. They would try and obtain as many details as possible about that person, like names, addresses, secret questions and answers. Then they would get in touch with that person's cell service provider, and they would social engineer their way through into getting a new SIM card sent out, which is under their control. They'd then put this into another phone and they'd have access to everything, and you'd have access to nothing. So then they can start logging in as you, they can receive the two-factor auth codes as well. It's a very scary scenario, and it's one that you should definitely hope does not happen to you. So what's the alternative then? If SMS auth can be broken, what's the alternative? The alternative is app-based two-factor authentication. This would use a constantly rotating one-time code that the app presents to you, and it's in constant communication with the service to invalidate and create new tokens all the time. Some of the common examples of this that you'll probably run into already are the Steam Authenticator and the Battle.net Authenticator. These are, of course, there's tons of examples out there in the wild, but I can imagine these are the two which would be most familiar among my audience, so you guys. Some of the common providers that actually offer this service are Authy and the Google Authenticator. As far as I'm aware, both of these services do allow just about anyone to integrate their application with it, so it's worth going and checking out the docs for these and seeing what information you can dig up. So now we need to move on to something a little bit less pleasant. We have to look at the worst case scenario. This is one of these scenarios that you do not want to figure out on the day. You want to know about this ahead of time. And in this instance, our worst case scenario involves the user's device being out of commission. So whether that's lost, stolen, met its untimely demise with the toilet, regardless, whatever's happened, the device is no longer something that we can use for two-factor authentication. The problem being, on whatever service you're building, two-factor authentication is mandatory. You cannot log in without it. So what exactly do you do? What you would do in this scenario is you would use recovery codes. So when the user enabled two-factor authentication on your service, they should have been presented with a whole list of codes, and they should have the mechanism to download these somehow, whether it's CSV, text format, or whatever, as long as they have the facility to download these codes somehow and store them somewhere safe. Next time the user goes to log in, they should be able to enter one of these recovery codes as the two-factor auth code. What you'd then do is you'd take this code, you'd verify it against your database, and you'd recognise that the user is in essentially recovery mode. So a good thing to do at this point, a good idea would be to, if 2FA is actually something you can turn on and off, it'd be a good idea to automatically disable two-factor auth at this point. It would also be a good idea to prompt the user to change their phone number, and it would also be a good idea to do any re-authentication that you have to do, say with any other services or with Authy or whatever two-factor auth apps are in use. And most importantly, train your support team. If you have a support team, you must train them how to handle this scenario. As well as this, make sure you give them tools that they can use to do this for the user. It makes you look good, and everybody loves a support team that's capable of handling worst case scenarios. So a quick recap of two-factor authentication. It's commonly referred to as an onion strat because there's many layers of security involved. I have deliberately stayed away from multi-factor authentication, or MFA, in this particular part of the talk because MFA gets very deep, very murky, very quickly. I like to consider two-factor auth as kind of fitting under the umbrella of multi-factor auth, but there's a lot of people that disagree with me there. So it'll be up to you to do your own research on multi-factor auth specifically. The way that it works is you create and send a token to the user via an SMS provider or via an app. You do this before you issue tokens or complete the auth process. When the user enters their first set of credentials, so email address and password, this is one step in the process. You must now complete a second step before you are actually authenticated. If either of these steps does not complete, the auth process does not complete. Next up, implement a recovery code system. Make sure that you can handle a scenario where two-factor auth is mandatory, but the user cannot actually use two-factor auth for whatever reason. Again, phone has been lost or stolen or met its untimely demise with the toilet. It happens. Lastly, train and equip your support teams to handle the worst case scenario. They must be able to handle this because it makes you look good and you don't want them escalating calls directly to your desk. So that's two-factor auth out the way. I was going to have a look at some of the questions which I received during this talk. The first one from PHKDX. Twilio has a free trial, right? 12 months if I recall correctly. I believe Twilio does have a free trial. I know that Nexmo definitely has some form of free trial. I can't remember what the details are off the top of my head, but it's definitely worth looking into. It's worth playing around with as well because it's free. A point that Canadian Vice wanted to add on to this was that Google, Authy, LastPass Authenticated, Battle.net, Steam, a whole bunch of others, it's worth noting that many of these apps are interoperable. Yep, they absolutely are. A point added by Not a Fed and OTP, that's and OTP, one word. It's a free and open source app, it's a Google Authenticator alternative. Thank you very much for that, Not a Fed. I'll add that to the resources channel, like I said I was going to do during the stream. Another point that Canadian Vice brought up, some of the discussion about whether SIM swapping is an actual threat. He brought up that SIM swapping is not an idle threat. Linus from Linus Tech Tips had this happen to him and he was completely locked out of just about everything. It is a very real threat. I'm very glad you posted that in there. Very good example. Thank you, Vice. Got a question here from Canadian Vice. Can I get those codes after I've enabled two-factor authentication because I didn't download them? This would depend entirely on the service that you're actually using. You might have to contact support and see if they can get you those recovery codes somehow. Otherwise, I'd probably try disabling two-factor auth and re-enabling it. Maybe it will trigger a new set of codes to be generated which you can download. Got a question from Swan X1. Should the recovery codes be deleted after use? Should the recovery codes be hashed in the database just like passwords? I would tend to delete the codes after they've been used just so there's no possibility of it being put back into circulation again. Just that's it, this token's gone now, bye. The second one is one that I haven't thought about before, whether this should be hashed or not. This could be a very nice security step that you could take for your users. The only downside that I can think of there is that your support teams won't be able to get the codes back out again for the user. Although I suppose really if the user hasn't got their recovery codes, say they didn't actually make a copy of them and they do need one, there's probably no harm in just generating recovery codes again on demand. So yeah, I really like that question. That's a great one. Thank you very much for that, Swan. So with the questions out of the way for two-factor authentication, we're going to move on to caching. Again, this is that thing that makes front-end developers mad. That's why I like it. In a nutshell, caching is all about storing a thing which is slow to access or to compute inside a fast thing to achieve maximum zoomies. Lots of technical terminology here, please try and keep up. An example that I'm giving here, a very abstract example with no real basis in reality, is an extremely complex mathematical operation that takes roughly 30 seconds to compute. Let's say it takes 30 seconds every time on the nose. In this scenario, you'd compute it once, you'd do this ahead of time, and you'd put this in the cache. And then in the future, instead of recomputing this thing over and over again, you just pull the result from the cache. Because again, we're going to assume in this scenario that it's not changing. Caching is a very common strategy for handling extreme load scenarios. One of my favourite examples of this is the Steam summer sales. I think it was back in either 2017 or 2018, Steam actually endured an incoming load of 5 terabits per second of traffic. To put that in perspective, the average home internet connection in the UK is 70 megabits per second. That's 5 terabits per second. Oof, mind absolutely blown, blob sweat. But it goes to show the power of caching. Doing something as simple as computing ahead of time and putting into a high-speed storage, that is enough to mitigate 5 terabits per second worth of incoming traffic. So how exactly would this sort of thing be accomplished? There's lots of different methods that you can go about when you want to start caching things. One of the first ones that people seem to get involved with, or that people definitely seem to get tripped up by, is browser caching, which happens on the client side. This all happens in the user's browser. One of the main downsides here is that you have very little control over this. The most control that you can hope to have over the browser side caching is by headers that you set on your responses, which the browser may or may not respect when they come in. It may not actually do what you told it to do. It might just ignore the header, and you'd have no way of knowing whether it's actually done the thing that you asked it to do or not. The other issue with doing browser-side caching is that it requires the user to run the thing first in order to build the cache, so the first run is always going to be slow for every user. An alternative, one that you might run into a fair bit when you're doing backend development, is in-memory caching on the server side. This is good if things are running on a single server. It's extremely quick and you can build it ahead of time as you need. Another alternative that you can use if you don't fancy doing in-memory caching is you can use something like a key value store, something like Redis. I know that key value stores are strictly speaking caches, but they do seem to function really well as a cache, which seems to be one of my favourite use cases for these. It's still sort of in-memory, especially with Redis, because it's volatile, so if you stop the service or restart it, all the contents of the Redis database disappear. But you do have the advantage here of you could go and put this Redis node on another server, which sits in front of like your database server where the heavy computation stuff goes on, and you could just send traffic to this Redis instance and it could just pull values out of there instead. Nice and fast. One of the last ones that you seem to get to is distributed caches. Now the reason I've put yes rather than client or server side is that when you get to this kind of requirement for performance and scalability, you tend to know exactly what you need, and it's usually something that can't be provided by off-the-shelf software. So you tend to build your own when you get to this point, and it could be any number of weird and wonderful methods. It's time to look at a couple of the common caching pitfalls. The first one is purging the cache. This is something that I almost guarantee has tripped everyone up. One of the biggest problems is that purging the cache is not straightforward to do, especially if you are relying on the browser cache. The other problem with this, which I forgot to put in the slide, is that if it requires user input, all of a sudden it's a badly designed system. If you're not capable of clearing or purging the cache yourself without some user involvement, some help from the user, it's not a great design for the system, and you need to try and find a way to mitigate against that. The second big one which trips people up is data security. Be extremely wary of caching data which you'd usually have to log in to see. An example of this, which Canadian Vice called out in the chat, he predicted this ahead of time, was the Valve horror story from a good few years ago. I can't remember which year it was specifically. But over the Christmas period, they were having their usual winter sale. They were spinning up lots and lots of caches to handle the insane amount of load. Lots of people that suddenly have lots of free time over Christmas. So they started caching more and more data, and someone decided to make the call that they were going to start caching things like users' profiles. Now this is bad for a whole bunch of reasons. The first one being that you cannot guarantee which cache is going to be hit. Their cache was really heavily distributed across hundreds of servers all across the world. You don't actually know where the data is going to end up half the time, so you don't know which cache it's going in. You also can't guarantee the order of the requests that are coming in, so you can't guarantee that the same person who made the first request and built the cache is going to be the next person which pulls the same data back out again. This is basically what happened. They started building the caches of things like user profiles and, in the worst case, sometimes payment details, and people started seeing other people's details popping up as they were pulling data from different caches. This is generally really, really bad, so be extremely careful when you're caching data you have to log in to see. Accidentally pulling data from the wrong cache could leak users' data out to other users. Again, disastrous for its own reasons, essentially what happened to Valve. Access controlling a cache is an absolute nightmare. The general purpose of a cache is that it's supposed to be a wide open, high-speed store that just anybody can go and grab things off at any arbitrary point. That's where your speed gains come from. If all of a sudden you have to try limiting access to that and do an authentication process first, you've just completely killed any speed performance that you were getting out of a cache. So as a general rule, try to only put things in the cache which will be public anyway. The last one, which trips a lot of people up, it's tripped me up a fair few times in the past as well, is what I like to call min-max caching. Avoid caching absolutely everything. I almost guarantee that one of the first times you set up a working cache system, you will look at every single variable in your application and think, can I cache this? The answer is probably yes, but just because you can doesn't mean you should. So again, be careful, keep data security in mind, and keep purging the cache in mind as well, because otherwise you cache too much stuff and you end up going back into problem 1, and it's just a vicious cycle of problems. It just feeds into itself over and over again. So that's caching. We'll do a quick recap. For the most part, in-memory caching will get the job done in most scenarios for caching. Experiment with different types of caching and see what works for you. Second big one, avoid caching absolutely everything, because this leads to problems updating anything because everything is cached and all of a sudden values are not changing when you expect them to. Be very careful caching data that requires authentication to see it. Leaking data is always a disaster. So with that recap done, I'm going to have a quick look through the questions in the Discord chat. We have an excellent question from why are caches fast? How are they different from a database, those that write to disk specifically? The reason why caches are so much faster than pulling things from a database is that they use basically faster storage. If you're storing things in memory, that's going to be orders of magnitude faster than raw disk access, which is going to be orders of magnitude faster than a database access going to disk. As well as that, accessing data in a database is going to be orders of magnitude faster than accessing things over HTTP. So it's basically coming out of a faster storage space. Got a question here from Plop, also known as Polar Bear, one of our long-suffering admins here at devcord. What are some important things to cache in an application? I would generally say that things which are accessed frequently but don't change frequently would be ideal to go in a cache. The reason why I'm giving you a very vague, very grey explanation of it is that because without being 100% up to speed with whatever it is that you're building specifically, I couldn't really say what would be good to go in the cache. It depends entirely on what it is you're actually building. Cool, that's all the questions to do with caching, so let's move on to my favourite topic of tonight's talk, which is ORMs. These are my favourite thing in the world for keeping you sane when you're working with databases a lot. The first reason I love ORMs, writing SQL is a pain in the backside. Is it a bug in the business logic or is it a bug in the SQL? Updating database schemas is a pain in the backside. Colleague didn't bother providing SQL queries for this whole bunch of new tables that is introduced in this new feature. Indexing, foreign keys and constraints are also a massive pain in the backside. These are my biggest pain points working with SQL in general. I like to abstract all this away, and the way that I do that is with an ORM. So it'd probably be a good idea to tell you what an ORM actually is. It's an object relational mapper, that's what it's called. It's like a layer that sits between your business logic and the database, translating instructions that you make in business logic land into SQL in database land. So for instance, the method getCustomer with an ID of 1 would get mapped into select everything customers where ID 1. Now, you might be thinking that that's not particularly impressive, I could do that myself in 5 minutes. Yes, you probably could, but imagine it in a scenario where you have really insanely heavily relational data. So we'll imagine it from the context of something like a customer relationship management system. So you'd have, say, customers. Each one of these customers has multiple sales. Each one of these sales can have multiple products, and then multiple products can have multiple variations, and then multiple variations can have multiple SKUs, and it just keeps going on and on and on and on and on like that. Do you really want to write every single query which covers all of these tables by hand? No, of course you don't. You're not mad. You're not an animal. Use an ORM. One of the other big advantages of using an ORM is that it manages your schema for you as well. So it usually includes tooling, I know Doctrine especially in PHP land does. It includes tooling which can look at your entity classes, your definitions and stuff, and it can work out what type of database schema you actually need to accommodate it. And the last thing to mention here is an entity class, which is literally just a class that represents an object. That's literally it. So coming back to my CRM scenario, you'd have, say, a customer, you would have sales, and you would have products. All three of these are related to each other. And if you were to create these three classes for customer, sale, and product, the ORM would look at these three and realise that you need 3 different tables, you need sale ID needs to know what, sale needs to know what customer is looking at and all this sort of thing. It will work this out for you based on the definitions you make in your business logic. On to the next topic here, which gets really weirdly controversial. I've actually named this quite badly. It should have been data access patterns, but instead we're going with ORM types because I couldn't think what the actual term was when I was putting the slides together. Apologies. So this one gets weirdly controversial because there seems to be 2 main camps, 2 main schools of thought about this. We have the first one, which is repository pattern. And a lot of people like repository pattern because it focuses on the domain. It means that you're not thinking about tables and rows and columns and indexes and foreign keys and blah, 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 blah. You're thinking about customer sales and products. Instead of working directly with records from the database, you work with a repository, which is like an abstraction of rows and columns in your database. So instead of manually updating a record, you tell the repository that I'm making these changes to this item, and it will go, okay. And then eventually it will do all these operations at once. So it's kind of like it's staged almost. Repository patterns, in my experience, seem to work really well with super heavy relational data. It tends to take away one of my biggest pain points with a lot of ORMs, which is the order of operation. A lot of the time, if I'm dealing with lots and lots of reads and writes in, say, like a single response to a request, one of the last things I want to have to worry about is whether I'm doing everything in the right order as well, because then it usually means that you have to go into all kinds of weird hacks and jumping around inside your code base, and it's just not great. But with a repository, a lot of the time, I can just, let's say I'm creating a new sale. So then I could go and get the customer first, and I could get the products, and then I could get the sale, and then the sale is already tied to a customer, so I just need to shove the products in there, and it doesn't matter what order I do things in. The repository just handles it, and it's marvellous. It's intelligent enough to work out what order things need to be done in, and then it just does them in the right order. The exact opposite of the repository pattern would be active record, which is focusing a lot more on the implementation. So you are thinking about things in terms of tables and rows and columns and foreign keys and blah, 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 blah. You basically pull a record, work on it, save it again immediately. It's a lot more hot, is what some people call it. It's like hot access for data. The thing that I'm not massively keen on with active record is that it requires a lot of fudging. So that's the aforementioned jumping around in your code base to make sure things are done in the right order. That's one of my main pain points with it. It puts all of the responsibility for that back on the developer. So instead of thinking about things in terms of users, customers, sales and products, you end up thinking about things in terms of columns, tables, rows, blah, blah, blah. And that's not great. You're being paid to solve a problem. You're not being paid to build a database schema. There's my other point that I did in the wrong order. See, order of operations. A repository would have taken care of that for me. Again, this is sometimes described as hot access for your data. Now, the reason I've done a fairly poor job explaining this and not really going into any detail is that I really do want you to do your own research on these. It's surprisingly difficult to explain the differences between these 2 patterns without getting bogged down in lots of technical detail, and realistically, you're not here to drown in technical detail. You're here to learn concepts and patterns, so then you can go do your own research when it comes to nuts and bolts. So that's all I've really got to say on ORMs before I start running away with it. So might as well just have a look at some popular packages just before we move on to the questions. So the first one, which I like a lot, is the Doctrine ORM. This is a repository pattern ORM for PHP. I do thoroughly recommend this if you're working with PHP. It's absolutely magical. It was my battle buddy for years, was Doctrine. Another one, which you'll get with Laravel out of the box, is the Eloquent ORM. This is an active record ORM. So it's kind of the opposite of Doctrine. Eloquent's still very good. I just much prefer Doctrine. Type ORM is a good one for TypeScript. Oh, by the way, RP and AR in the brackets, those are repository pattern and active record respectively. You have Sequelize for JavaScript and TypeScript. I do kind of prefer working with Sequelize, but the problem that I've had with it before in TypeScript is once you've actually built your code, you built the TypeScript into JavaScript, it was having some issues actually finding my entities again, which was kind of a pain. Entity Framework for .NET, I love this one a lot. It reminds me of Doctrine, but it's in a much nicer language. And Hibernate, which is a bit of a weird one. Hibernate it doesn't really pick a side, it kind of straddles between the two and kind of does its own thing. It's a little bit weird. Very popular, very powerful ORM. It's just a little bit weird in the way it does things. So that's all the slides that I've got for ORMs. I didn't actually do a recap because, well, don't really need one to be honest. I didn't go into all that much detail. So we'll have a look at a couple of questions and then we'll start closing things out. Got another question from Plob, aka Polar Bear. What's your preferred ORM type and why? Favourite ORM package and why? My favourite ORM type / data access pattern is the repository pattern by a country mile. I absolutely love it because it means that I don't have to think about things in terms of databases, columns, rows, foreign keys. I can think about things in terms of customer sales and products. And my favourite package, I think right now it's probably Entity Framework because I'm doing a lot of .NET again. But I really like .NET, I absolutely love Doctrine, and TypeORM has surprised me as well. It's very good. Another question here from Not a Fed. What do you think about query builders? I think query builders are quite good. If I can't use a full fat ORM, I will tend to use a query builder, just because I absolutely despise writing SQL. I just... If I need something that's super performant, like every millisecond counts, I will handwrite SQL. But for the most part, the kind of performance penalties that you get from running an ORM or a query builder, I will happily take that trade-off in exchange for not having to write SQL. I am totally fine with that. There's a follow-up question here from another one. Why do ORMs introduce a performance overhead? This will be in response to the performance overhead I mentioned answering the last question. The reason why there is a performance overhead with ORMs and things like query builders, ORMs more so, is there's just basically more steps to it. The ORM does a lot more work in terms of figuring out what it is that you asked it to do and how it's going to turn that into SQL, and it just adds a lot more steps to the process before it actually runs the query. And Lost added to that as well. He said that hydrating the models is a surprisingly expensive step. Hydration is the process of taking the data from the database and then injecting it into a class. So if you select all from customers where blah, and you have a customer class, the ORM would take care of taking the data from the database and then working out this is the ID property from the database, that's the ID property on the class, we'll inject that into there, and so on. It just does that all the way through. Another good question, one that I'm going to run away with a little bit from Not a Fed. He mentions lazy loading of ORM relations. So I'm going to turn this into a question that I wanted to see, which was, what's the difference between lazy loading and eager loading? Lazy loading is when all the related properties of an entity are not loaded with it. They're not loaded until you actually request them. So if you were to load a customer and then you wanted the sales, if you look at the customer before you call get sales, there's no data there. But when you call get sales, the sales data is actually pulled in as it's needed. The exact opposite of that is eager loading, where the query will be a bit slower, but every single piece of data will be available immediately. It doesn't go and load it when you ask for it, it's already there. Cool, and that is the end of all the questions for the ORM. I'd like to thank you all very much for tuning into, well, I say tuning into, you came and found the video for week 4. Once again, I would just like to apologise that this is not the live video that you were expecting. We ran into unexpected technical issues which prevented us from actually streaming and prevented YouTube from archiving the stream for us. We have resolved these issues and it should be all smooth sailing going forwards from here. So I'm very sorry if I've disappointed you. I hope that if you did tune into the live stream, you did enjoy it. I hope this was a faithful recreation as well of the live stream. Needless to say, we have resolved the issues now, so going forwards, week 5 topic of the month, which is the last one for Backend. I know, I'm as sad as you are. This will be another live one, live streamed on Discord and YouTube. And hopefully, fingers crossed, all goes well and YouTube automatically archives for us like it was supposed to do last time. So once again, thank you very much for joining. I hope you've enjoyed, I hope you've learned something, and I will catch you all next week. Thank you very much. Bye-bye.